Hello, Jiaju.
Oh, Andreas, and nice to meet you.
Likewise.
Yeah.
So I'm here with Jiaju Zhang from the CTO office in APAC. Jiaju is the chief architect for China, and he's explaining to me now what he's got here. So what did you bring to ITAP this year?
Today, I will demo you about a robot to catching the ball. So we can have a ball throw on top of that, and then there is a camera in it. So this camera is just like your eye. Your eye gets the signal transferred to your brain. Your brain is the real-time kernel. So this bus can be put in your factory. So your arms, your neural networks should be the high-speed networking provided by Intel. So this is we call time-sensitive networking. So it is inside this box. We have the easy networking to do the high-speed, low-latency network traffic, and then it will get the ball.
Beautiful. So I see Moxa in here and I see Mitsubishi in here. A lot of cabling, ABB, fuse boxes, power supplies. So this is the brain basically. And it all runs Red Hat Enterprise Linux 9.4. Is that what he said?
Yeah, because Red Hat, we have a broad ecosystem. We can have different hardware and software vendor. Together, we band all the software inside the same platform. We are a platform provider.
Beautiful. Thank you so much.
Thank you
for explaining us the great demo, and we're going to move on to the next one. Let's go. Alekh,
Hi.
welcome to the Red Hat booth. Alekh works for ATS Global, which is a global OT systems integrator, and today he brought a very interesting looking miniature plant to us. And yeah, tell me what's going on there. What's the technology behind it, and how does it work?
Yes, so it's an interesting small project that we did together. So the idea behind this is that we wanted to show the capability of Red Hat with soft PLCs. So in this system, we are not using the traditional PLC, we are using the soft PLC along with Ignition SCADA and Postgres SQL. But the catch is all these three systems are installed in a containerized environment. And as we can see, it works seamlessly, properly. That's good.
Very good. Yeah. Thank you, Alekh. So you've got decades of experience in the OT sector, right? What's your feel on and your view on those new technologies where we take proven enterprise IT solutions and technologies into the OT world of industrial automation?
It's certainly an interesting prospect, but manufacturing environment is a little bit different. When we look at the IT solutions, they are definitely proven in financial sectors, but we still need to prove them to the manufacturing sector because they prefer more of a reliable solutions. They don't mind spending much as long as the things are proven, the technologies are proven, and it works properly fine.
Beautiful. So we'll be up for nice 10 years of new technology that Red Hat brings to the OT sector then, if I understand you correctly.
Yeah.
Awesome. Thank you very much. Thanks for joining us in the Red Hat booth, and let's go look at the next one. David Rapini.
Andreas.
Good to see you. You are the global strategist for industrial automation at Red Hat.
That's correct.
What have you brought to us at the Red Hat booth today? Can you walk us through, please? Thank
you. So our demo here today is really talking about a major change happening in the industrial automation space. We see it being much more of a software-driven solution in industrial automation. Instead of the traditional roles where you had a proprietary hardware piece of equipment that had a very lockstep piece of software that was running on it, where you had monolithic Windows applications that were difficult to maintain and difficult to update, where you had systems where you had a bunch of different little components that when you wanted to integrate them together, you had to write a bunch of custom code. We see that market changing very heavily to be more software driven based on open source and based on open standards to allow that interoperability. So we partnered up with Intel, and Red Hat and Intel released a platform to allow that sort of technology to exist and run very seamlessly on the plant floor with the reliability and the performance that you need in the OT infrastructure, taking a lot of the IT technologies and bringing them down to that OT space where they can take advantage of a lot of that interesting stuff.
Okay, great. So looking here on this booth, it looks more like server grade hardware, whereas over there it looks like smaller form factors. Can you walk us through what does that signify, this box here?
Absolutely. So this platform that we're talking about here that we're releasing is very scalable. So you can be running content in the cloud, on a server, on an IPC industrial computer, all the way down to a small ARM device, and still leverage the same technologies, the same tool chain in that platform to develop things that are common. What we're showing here is something we call the ACP, so that's Advanced Compute Platform. And the Advanced Compute Platform is really sort of that server grade on the plant floor layer equipment that can do things like virtualize Windows workloads, run them like they were containers and still manage them like containers, but if you still have those monolithic Windows applications, you can do that. Obviously, Kubernetes stacks, things like containerized applications. We have very modular solutions running microservices. Managing those from this ACP are very common as well. And then another big thing this does, it also does system management. So being able to upgrade firmware or patch things down the stack or even on itself is some of the capabilities that this provides using tools like Ansible.
Beautiful, thank you, Dave. So
Sure.
let's look onto the next booth and see what Dave's got there for us.
Absolutely.
So I see a lot of moving heads and blinking lights and buttons and, oh, NVIDIA. So what have you got here, Dave?
Yeah,
for us?
absolutely. So as we're moving down the stack, we're more at the I/O layer here at the smaller components. So I/O modules, motion control, servo, a lot of the stuff can be managed from the top layer. So being able to manage firmware revisions, updates, patches, taking care of all of that content is very easy at this layer. We also run that product down on device edge down on a smaller platform. So running on an ARM chip is available as well. So if you've got a small platform that you want a cheaper, low cost, lower energy solution, you can do that on this architecture as well.
Beautiful. Well, thanks for the tour, Dave.
Absolutely.
I hope you had a great day and I'll see you around.
I did, thank you.
Christopher Tan, welcome to the Red Hat booth. You work for Intel and you got a very interesting screen in front of us. So the tagline says generative and predictive AI for manufacturing. Tell us, Chris, what have you brought to us today?
So today what we are showing here is a capability, and we're trying to show 3 different AI workloads on the platform. The first one being a video AI model, which allows us to identify people and whether they're wearing safety equipment or PPE. This is a use case for safety in a factory. And then the second model that we're running is a image to text model, which translates what's on the video into text. And the last model is really kind of like a chatbot model where we send that information into a large language model in which we can ask questions there in a more user-friendly way, like what is the PPE compliance, how many people are on the video, and so on. At the end, we're running 3 different AI workloads, or what they call 3 multimodal workloads on a single platform on Red Hat OpenShift AI, on top of Intel infrastructure, and in this case, it is a core CPU and an ARC GPU on a desktop platform.
Beautiful. That sounds like a really good value proposition, right? A single platform, multiple models, multiple use cases. We can even do GPU slicing, and I think that's a really strong value prop from Intel and Red Hat in the AI space. Thank you very much, Chris. I'm moving on, and come follow me. Jey Paulraj.
Hi, Andreas.
Good to see you here.
Good to see you here.
You've got a really fancy screen behind you, so tell us, what are all those fancy colors behind you?
Yes, so observability, in a nutshell, observability is measure the inner state of your system, complex system, how it is performing it. Not only the application level, it also perform the infrastructure level as well. So here, we build the solution specifically for distributed and the edge system. So we have a multiple device. We have observability installed on multiple device. One is running on India, which is a Raspberry Pi, and one is running on here Export Center. So it's collected data, not only like applications, like the memory consumption, CPU consumption, and the power level as well as the infrastructure level, and sent to the centralized data center where analytics and business people can visualize the data and make a decision out of it.
And I see there edge sustainability. What is that about?
So the edge sustainability is we use a Kepler. Kepler is a framework which is measure the power consumption of your CPU, how much CPU consumes the power, and gives the output to the dashboard.
Beautiful. So thank you very much, Jey, for joining us today at the Red Hat booth.
Thank
And
you.
with that, we completed our tour. So thank you very much for watching. I hope we've given you a great overview of what Red Hat is about in the industrial automation space. You've seen many different solutions from low-level Purdue model, level 0 in 1, control logic, all the way up to distributed edge fleets and AI use cases. And I hope there was something of interest for you, and please reach out to the Red Hat team, and I'm looking forward to hearing from you. Thank you.